Today I will tell you how to use our surface analysis system for XPS. If you want to open the chamber and load your sample, first thing you need to vent it. For this we use nitrogen gas. We open the tank. Even if the pressure is pretty low, make sure that you still have some pressure in the regulator. This should be enough to vent the chamber. So open this valve, don't touch this one. This valve, this green valve here, this valve needs to be open as well. When the nitrogen gas is open, you are ready to vent this chamber. First step is to turn off the turbo pump. You turn off the turbo pump and wait a minute or two. So you can switch off the mechanical pump. Just be careful of the cables and just flip this switch. After you switched off the mechanical pump, you are ready to vent the chamber. Switch this valve, this switch from run to vent. After about 30 seconds, the door should be open. The chamber is vented. You can see the door is open. We have the stage with the old sample here. We'll use the same stage, which means we need to take this out. Just be careful, don't drop it. There is an old sample. Either you discard it, or if the person in front, before you ask to save, just save it. Then you need to remove this, put your carbon tape, adhesive carbon tape, and on top of it attach your sample. The stage has a flat surface on one side and round on the other. This flat surface needs to be facing the door after you load it again. Now also there is a hole at the bottom which will fit this post here. Just make sure that you place properly the stage after you load your sample, and align so the edge is facing the door. You are ready to close the door and pump the chamber. To pump the chamber, once you loaded your sample, just first close this switch again from vent to run position. Turn on the rotary pump, mechanical pump. Final stage, once the vacuum is pretty good, after about 5 minutes you can start the turbo pump, meaning you flip the switch from the off to the on position. After the pumping has started, you don't need nitrogen anymore, so just make sure that you close tank and close this valve and also the other valve, the green one here on the line. After at least 2 hours of pumping and after you've been helped with transferring the sample from the airlock chamber to the analysis chamber, you are ready to prepare your measurement. First thing is to locate the area which you will be measured. And one thing to remember is that you need some light. So you need to switch on the light. Make sure also that the gun is retracted before you move the sample. The ruler should be between the 20 and 30. Here are the controls for the movement of the stage and your sample. This one allows to move in the X direction. This one in the Y direction. Just remember, not turn this knob, just the outside knob. And the same here. This one is for the Z height, for the height movement, which is used for focusing. Also, don't touch this one, use this one. Now you need to bring your actual sample to the field of view, which is the middle where you see the cross. First you can use X direction, which is this. So you go from the edge of the stage to the point where you start to see your sample. Here we have, this sample has some powder, which we start to see right now. We go to the area where there is enough powder and as little background as possible, maybe somewhere here. So this is the X direction. Sometimes you need to move in the Y direction, which is this direction. Finally, you may want to use the focus, which is Z direction. You want the cross or the area which is directly under the cross to be in focus, like this. So something like this would be bad. Something like this would be bad. You really want the middle part to be in focus, like this. Once you know which area will you be measuring, now you need to bring the X-ray gun close to the sample, just to have as good signal as possible. So right now the gun is retracted, and the ruler, which shows us how far, is at 30. You need to bring it to about 50. Sometimes you may touch the sample, and then if you see this, then you need to retract maybe by 1 or 2 division. But for most samples, you should be able to go close to, you can be at 50, basically. So I'm bringing it right now. I'm at 45 at this moment. And right now I'm at about 50. So this is where you want your gun to be. It's very, very close to the sample. When you are bringing the X-ray gun close to the sample, sometimes for samples which are slightly higher or they are farther away, before you reach 50, you may see a shift of the image. This means that you just touch the sample with the end of X-ray tube. At this moment, just back off a little bit, 1 or 2 division, and just stop there. Once you have everything ready in the chamber, you don't need light anymore. Just make sure that you switch it off. Before you turn on the gun, X-ray gun, and start the measurement, you need to make sure that the vacuum is good enough. 10 to the minus 7 is not good enough. You need to be in low 10 to the minus 8. To do this, in addition to ion pumps, which are on all the time, you need to use for a short time sublimation pumps, sometimes 2 or even 3 times. To do this, you need to press the filament buttons on this pump and just observe the pressure in the analysis chamber. First, the pressure will go up, actually both, the distribution chamber and analysis chamber pressure, they will go up, but then they will start to go down. So and the arrows will show whether the vacuum improves or deteriorates. As long as you see the downward pointing arrows, you can wait and just have the pumps on. The arrows disappear. Now we will start to see arrows pointing upward, like now. And so now you are ready to turn it off. So once your vacuum is good, the gun is close to the sample, you are able to start to prepare the spectrometer and the electronics. So first thing is just to turn main switches on all this equipment, the power supplies mostly, in this middle section. Just don't turn any knobs. Everything has been preset already. So this, you don't touch any of this. The only thing you need to switch in addition to the mains is this. You need to depress this switch and switch it back. So this light, green light or high voltage on, is on. And also you need to press this button so you enable this unit. Next step is to turn on high voltage on the gun. Press this button first. Make sure that everything here is in green, and then slowly start to ramp up the voltage. You need to go to 10 kilovolts. Right now it's 0.39, but this has to be very slow process. So we are slowly bringing it up. Right now we are at 6.16 kilovolts. We have almost 4 to go, but this needs to be done slowly. After about 2-3 minutes, you should be able to reach 10 kilovolts, but at the time the vacuum perhaps deteriorated, and you can see now we are again in up 10 to the minus 8 range. So use the same sequence with sublimation pumps to bring it to much better value. After second sublimation pump cycles, you should be in the low 10 to the minus 8 range, which is good range for the measurements. When the vacuum is good, you have already 10 kilovolts of voltage on the gun. Now you need to produce emission current, which will be your beam. You want to reach 9 milliamps of current. We'll do it in 2 steps. First, we will bring it to 5 using filament control, then from 5 to 9 using emission control. But first thing is to select which source you want to use. Magnesium source, which is filament 1, or aluminium source, which is filament 2. Well, let's keep filament 2, which means aluminium source. And first we will go from 0 to 5 using filament control. So this switch needs to be up, and now we need to press the filament on button, and we can start to bring the filament current up, and also at some point we'll see emission current starting to show up. This needs to be very slow process again. Just pay attention to this current. When now it should start to go up slowly. So again, you just turn this knob slowly, and you start to see that this number gradually will increase. You want to bring it to about 5 and then switch to the emission control. Before you switch from the filament control to emission control, you need to prepare the emission control knob to certain preset value, which is about 1.3. So it should be 1 displayed in this window and 30. So right now we have 1, 10, 20, 30. This is your preset value. So right now, and you can see at some point it starts to move fast, even if you almost don't touch anything. So now you need to just switch this one, and you are already in the emission control. And now this allows you to do it in a much more controlled way. So now you bring it to 9, also slowly. Okay. After we have our emission current and the beam produced, the vacuum will probably deteriorate because you will see some degassing, which means you may want to run one more time the sublimation pumps. For the measurement, you need to use this program, SPXWLC. We have a shortcut on the desktop. There is also a very similar icon for the presenter. This program is only for viewing the data, whereas for the measurement, you need to use this program. So just double click and open it. Here, just say cancel, don't open it, and just minimize this window. Now you need to select go to this toolbox menu and go to the setup card. Here you need to select XPS as your technique, and also you need to select which source will you be using. So we have 2, as I mentioned, aluminium and magnesium. Right now we are using aluminium, so just make sure that you select aluminium and then OK. Now next step will be to set the parameters for your measurement, which will be opening this menu, and you can set up to 10 spectra to be measured from your sample. Let me just show you how to run a survey spectrum, which is this wide view spectrum where you want to know what elements are in your sample. Make sure that this button is in the binding energy mode. Not if you click it, it will change to kinetic energy. You want this to be binding energy, so BE. And now we'll use the first channel, which means we'll check this box. We'll use this channel for the survey spectrum, for programming the survey spectrum. Typically, for the aluminum source, you can run from about 1200 electron volts to 0. The step size should be minus 0.4. Number of scans, this you can select. We can just run one scan, and the dwell time, first run a very quick scan, this 0.01, just to make sure that everything works fine, but then we'll change to 0.2. So this is 0.2 is your normal scan. Now this is the pass energy. This shows, I mean, this tells us how what's the resolution. So for this scans, you need to select this CAE 100. This is for the survey scan. This should be the pass energy. So now let's go to very fast scan first, just to make sure that everything is working. And we will only run the first scan, which means you have only this first box checked. And now you are ready to go and start the scan. We run this first fast scan just to make sure that everything is correct, that we have the beam setup of the program are correct, everything is as it should be. If there is a problem, try to correct it. If you don't know how to correct it, look for me. We run this fast scan, everything looks good. Now to stop it, you really need to press this button, which gives this information, kill data. Don't be afraid, your data won't be lost. Just press this one. Confirm that you want to stop it or discard the data. And now we'll run the same thing but much slower. We'll change the dwell time from 0.01 to 0.2, which means it will be 20 times slower. Now you can see this one scan will take 10 minutes, and that's what you typically have to do first. And just press run button, which will switch to go, and now you have to wait 10 minutes. So after 10 minutes, the measurement is done. You will see this circle completely black, and it says done. Just to finish, you need to again kill data. It doesn't kill data, but this is how you end the execution. Make sure that you uncheck this box here, because if you don't, you can overwrite your data accidentally. So this is our survey spectrum. It has number of peaks for elements which are present. So in this particular sample, we have oxygen peak, carbon peak, and palladium peak. Now, how do you know it? You can find out in this book, which should be here in this room all the time. The book has a first section, which is introductory section about the principles of techniques. And then it has main section with pages dedicated to specific elements. So, for example, palladium. There are 2 pages for palladium. One shows the spectrum for palladium when you use aluminum source, one when you use magnesium source. You can see number of peaks, but you always look at the strongest peaks. So in this case, palladium 3D peaks, 3D half and 5 half and 3D 3 half, which are zoomed in here. So this is a this is the survey spectrum. This is high resolution spectrum of this 3D peaks, and that's what you should be able. You should measure, because this gives you the information about the oxidation state or valency of the element. This is what we will be setting up right now. When you want to measure high resolution spectra of your peaks, let's say palladium peak, just first zoom in on the peak, draw the box around it. You will see this dashed line box around your peaks, and then press the magnifying glass icon. This will give you just view on this one peak. and this allows you to set up correct ranges for the measurement. So let's say we'll measure between 360 electron volts, which is from this point, to maybe 340, which is this point. You don't need to measure wider than this. So now we in channel number 2 we'll set up the parameters for this peak. So we'll start, you always start from the higher value, which is 360 in this case. Lower value, end value will be 340. Now for high resolution measurements, you want a step size at least 0.05 or smaller. 0.05 is the minimum, the maximum step size you want to do to use. Now, number of repetitions depending on your number of scans, depending on the intensity of this peak. But let's say we select 10. The dwell time will be 0.2 again, and now the pass energy for high resolution scans should be CAE20. And you can see that with these parameters, the spectrum will take 14 minutes to be collected. So we just confirm this, and we just run it. We won't wait an entire 10 scans. I will just stop it at this moment. Just press this button and then confirm. We ran 4 out of 10 scans. You can see that the spectrum can be further improved if you run more scans. There is still a lot of noise, but for this training purpose, we just stop it here. Now the final step, if these are your survey spectrum, which is this one, and if you want to zoom out, just press again the magnifying glass window. So this is your survey spectrum, which we just measured, and your palladium 3D spectrum. Now we just want to save this. Make sure that you again, this time you have both boxes checked, because only the spectrum which has checked box will be saved. So make sure that you check these 2 boxes, and then click this floppy disk icon above these boxes. It will open this Save As window. Select the folder where you want to save it. We have a folder Data1, and each user will have their own folder here. So, or if you don't have a folder, create one. Create a separate folder for your sample and just add a name. And one important piece of information: select format .1 as your standard font format. You can add some notes, but this is not necessary. Also, you can save the same data using TXT format, which will produce XY data. Again, you can add notes, but this is not necessary. So this is saving the data. Now, if you want to review the data, go to the desktop and open the presenter, which is this icon. It will be a very similar software which will allow you to view your data. To open the data which we just saved, click this icon, Read File icon. It will open this window. Find the folder where you have saved it. I will look for it. This is the one which I saved just now. It should have 2 spectra, a survey spectrum and your palladium spectrum. So at least you can see what you have saved. After the scan is completed and the data saved, and you are ready to leave, you should turn off the whole electronics, which is this module. Don't touch this module. So first thing you want to do, you want to reduce the current to 0. Now you can do it fast. So just go to 0 using this knob, switch to filament control, and then turn to 0 on this knob. then turn off the filament. You need to bring the high tension to 0. Again, this time you can do it fast. And just wait till it goes close to 0. And then turn off high voltage. You should see the green button. Now the last thing is to turn off the mains on all pieces of equipment. The last thing you want to do is to retract the X-ray gun. So now we need to move it from 50 to between 20 and 30 just by rotating this screw here. It takes probably half a minute or so to go from 50 to 30. And this is pretty much all what you need to do. Normally we discard samples. One thing, always never bring a toxic or hazardous sample unless you discuss with me. Normally we don't really test any hazardous samples. There may be some exceptions, but you really have to discuss it with me. Also, second thing, normally we discard samples. However, if you want your sample to be safe and recovered, arrange it with me. This whole procedure was a standard procedure, basic steps. Sometimes you may run into some technical difficulties which you cannot clear. In this case, look for me in room 010 or call my number. If I'm not around, send me an email. And if you cannot continue, just cancel the session.